Hi everyone, Stephen here. So you've heard of NSX Federation, but you're not quite sure what it is or you don't understand the components in play. Hey, stick around. We're going to talk about that. This is going to be part one of a two-part series. So see you in a bit. Bye now. Hi everybody, thanks for sticking around. So why don't we get started? Let me get my iPad and webcam going. Okay, by the way, before we jump into this, hey, if this is stuff you're interested in, please subscribe to the channel. It doesn't take much. You just got to log in and click on subscribe. It's free. It helps me out. Without subscribers, there's no content, right? Yeah, so why don't we just jump into it? This is part one of a two-part series. This part will be basically just lecture. I've put together a bunch of slides, so we'll talk about the basic architecture and all that. The next part, I'm hoping to do that in another week, will be demo. Okay, I'm building my lab environment still for that. So anyways, let's jump into it. So what is Federation? Okay, so Federation allows us, well, to federate multiple independent NSX environments together. So I can, one, manage it under a single pane of glass. That's one example. I can go all the way up to 8 locations, as I mentioned. And technically, it doesn't have to be different locations. It could be in the same data center, but you just want to federate them all together to manage them to manage them as one type of thing, right? Another good example of this is consistent firewall rules across locations. So imagine you got a VM at one location or in one NSX environment, and you're going to migrate that VM over to another NSX environment or another location. Well, when the VM lands at that location, what firewall rules does it have? Is it like open to the Wild West? Anybody can access it? So you want to make sure that security posture follows the VM with it. It allows for us to stretch our networking and stretch our routing, which we'll take a look at. It has flexible configuration for local, regional, and global configurations as well. So a lot of times you may have local requirements. These requirements are just for this location, which is fine. And then you may have global requirements as well. So you can take advantage of that. And there's even regional requirements you may have. So you have that flexibility here. Can provide for operational simplicity in the data center, and it can simplify your disaster recovery solution. I will be putting together a video on disaster recovery with NSX, talking about federation and multi-site, but that will be maybe a few weeks down the road, or maybe sooner, who knows. So I'll be putting that together. So we'll talk about it from there. Also, ease of compute mobility. What they're referring to there is if I'm going to migrate a VM from one vSphere environment to another, like cross vCenter, vMotion, well, one of the nice things with NSX Federation, I don't have to worry about my network. My layer 2 network exists at that other location. I don't have to worry about routing. Routing exists over there. I just basically plop the VM over and rock and roll. Okay, so that's what it says, ease of compute mobility. So let's take a look at some of the components. All right, as I mentioned, you can go all the way up to 8 different locations, right? So here's location 1, 2, and 3. You can go all the way up to 8 if you wanted to. First thing I want to point out is a couple things. One is this thing called the Global Manager Cluster, and then we have Local Manager Cluster. So at each location, you'll have your 3 NSX managers. There's your control plane and management plane at each location. 1, 2, 3, 1, 2, 3. Up to 8 locations, that's what, 3 times 8, it's 24 of them, okay? Then we have this concept called a global manager. And again, you'll notice there's a cluster of them. So you'll have 1, 2, and 3 global managers. And you'll notice over here as well, there's another global manager cluster, but these are standby global managers. And there's 1, 2, and 3. So if I do the math here, 3 times 8 location is 24, plus 6 is 30. So this thing has a fairly hefty footprint, okay, with just managers alone. So each location you have your local managers, just like if you watch any of my NSX stuff, again, just think of it like that, right? Each local manager is responsible for its own location. It's responsible for the TEPs over there. It's responsible for the transport nodes, edges, and all that. So the local manager's still in charge of all those local objects. You can even have local routers and segments there, no problems. So local managers are responsible for the stuff in their site. The global manager is responsible for stuff like global objects and regional objects. Objects that you create that's going to span your locations. Maybe I'm going to have a gateway that spans this location, right? Or segments, or security groups, that type of thing. So global manager looks after global objects. Okay. Now you'll see over here, you can still access your local managers just like you do today, right? You know, you can still go in and manage them independently of each other, no problems. And again, that's, you know, using the GUI, the user interface, or the APIs. Or again, you could connect directly to the global manager and manage the global objects. So objects that are created by the global manager are technically called global objects or regional objects, okay? And the global manager needs to first of all, push that stuff down. Now, let's talk first about global manager, active cluster, and standby cluster. So again, we've got an active cluster here, 1, 2, and 3. So if you lose one node, you're still okay. If you watched any of my videos on node failures with the NSX management cluster, if you lose one, you're still okay. You lose two, this global manager is now down, okay? So you can now manually go over to this standby and you manually push a button saying, make this active. Okay. While all that's happening, if that was all down, all this stuff down here in the data plane still functions. Managers down here, control plane down here still functioning, right? So none of that's impacted by this. Okay. So I wanted to point that out. The other thing I want to point out up here, these global manager, these global NSX managers, it's just management plane only. Management plane. There is no control plane up here. Okay, control plane is down here. Okay, that's where your VTEP, MAC, ARP tables, all that kind of wonderful stuff resides. Okay, the other thing I want to point out is when you make a configuration over here, a global configuration, the active cluster will synchronize that or send that over to the standby. So the standby is up to date on that. Okay. Notice it's using this thing called an async replicator, which is relatively new because of Federation. And notice the port it's using, 1236. Okay. And now, when you're creating objects, the active global manager will, as I mentioned before, will sync it to the standby, so it's aware of it in case the active cluster dies, and it also has to push it down to each location. Okay, and again, notice it's using that config sync here. Okay, so it's using that async replicator port 1236 to do that. Now, I've got a little asterisk here. Basically, it says when required. So I mentioned that when you create an object, a global object up here in the global manager, it pushes it down to the local managers. Well, it only pushes it down to local managers that need it. So we have a concept of location. So this is location 1, 2, and 3. That's local. Okay, so the local objects, local. Then you can have regional. A regional could be like location 1 and 2. So I'm going to create an object that only spans location 1 and 2 because that's a certain region, right? Maybe that's United States and over here is Canada or something like that. So when I create that regional object, global manager will push it down just to the region. It will not push it over to location 3 because it doesn't need it. So that's why I put this little asterisk here. It does push down the configuration, but only if that location needs it. Okay. Yeah, so when required. Now, one of the questions I usually get at this point, I got a slide coming up on some of the requirements, is latency between the sites. So as of 3.2.1, latencies between global manager active cluster to standby cluster, so here to here, 500 milliseconds. It used to be, prior to 3.2.1, 150 milliseconds. Global manager cluster to local manager cluster. Again, that used to be 150, is now 500 milliseconds. Local manager cluster across locations. So local manager to local manager, that's what they're talking about. Again, 500 milliseconds. That's pretty cool. Then it's talking about this RTEP to RTEP for stretching your network, 150 milliseconds. So technically speaking, if you're doing stretch networking, what you're probably going to be doing, your latency between the sites is 150 milliseconds. Kind of negates this one up here. Okay? So watch out for that. That was a change in 3.2.1. And I'll talk about what an RTEP is, so don't worry. The other thing I want to point out here is, again, you deploy 3, as I mentioned before. Now, this appliance here, you may say, okay, Steve, I've deployed NSX management clusters before. I watched your video, great video, and I deployed that. Where do I get my hands on this global manager, right? Is it another appliance I got to download from VMware? And the answer is no, it's not. It's the exact same appliance that you're used to, you've been playing with, okay? You basically, when you go to deploy it, the first question it asks you is, what type of manager is this going to be? Is it going to be just like a regular manager, or is it going to be a global manager? Okay? So you would say global manager, then at that point you can make your active cluster and standby clusters, okay? So it's not a special appliance. It's the same one, but you're just saying, no, it's going to be for a global manager, and you would deploy it. And when I do my demo, again, not in this part, it'll be part 2. When I do the demo, I'll talk about that, okay? So again, up to 8 locations. So when we talk about networking now, we have the concept of stretched objects, okay? And this is one of the really cool things about Federation, is I could stretch my gateways. So notice over here, I've got my stretched tier 0. So I'm just showing 3 locations, again, all the way up to 8. So I'm going to create this object, this tier 0 object, and I'm going to say this object is going to span locations A, B, and C. So you would pick that, okay? So now that object is stretched across. Now you could also, this is called a global object, global, because it's stretching across all these locations, right? I can create a local object. There's a local right there. There's a tier 1, it's non-stretched, so it's just a local object, and I'm going to connect it to this global object, which I can do, no problems. You can do this all day long. I could also create, this is a regional object over here. Here's a tier 1 gateway, regional. Can't spell, can't write. And again, you can connect this. See how this regional object, this tier 1 spans locations B and C? Again, I could do something like that. Notice this other regional object right here. It's another tier 1 spanning locations A and B. Again, you could do that. And last but not least, you see this last tier 1. Again, this is stretched, and it's stretched across all locations. Okay, so you've got a lot of flexibility here. What can't you do? Okay, what can't you do? Just imagine for now that this stretched tier 0, just for now, let's just pretend that stretched tier 0 only goes across locations A and B. So that's only going across locations A and B. It's not going across C. So I'm going to scratch that off. So this one here, this would be a valid config. This would be a valid config. This would not be a valid config. And this would not be a valid config. Why? Because this tier 1 is in location B, which is correct, but it also wants to go in location C, where this tier 0 is not going. So if you're going to connect this tier 1 to this tier 0, this tier 0 has to span to location C. Excuse me, same thing with the bottom one. Again, if I wasn't going to make it span all the way across, it would be okay. So you have this level of flexibility if you want to make local objects, global objects, or regional objects, depending on what you want to do. Now, one thing I will say, here they're showing stretched segments and non-stretched segments, okay? Technically speaking, you create your stretched gateway, tier 1 or tier 0, and then when you connect your segment to it, it automatically makes that a stretched segment. So I don't go in and say, oh, I want to create a stretched web segment. I just create a segment and I attach it to a gateway that's already stretched, and by its nature, it's stretched at that point. So again, your gateways can be local or stretched, which I talked about. Your tier 1 span is equal or a subset of the tier 0. So again, your tier 1 here has to be, it can be a subset of this tier 0 at the top that it's connected to, or the whole thing. Again, totally fine. Okay. Various services are supported. The VPN service came out, what version? I think that was 3.2, if I remember correctly. But various services, there are certain things you got to watch out for. Partner integration, guest introspection. There's a few things you got to watch out for there. DHCP, if you're having DHCP on these stretch segments, it supports static binding only. So it can't be dynamic. So you have to assign IP addresses to the VMs, and those IPs got to be bound to that VM. Okay. Topology segments, as I mentioned before, the segments require your tier 0, tier 1, and the width of the stretch will be dictated by the gateway it's connected to. Okay. Now, let's talk about locations here. Now, before we jump into looking at how we can do this, let's talk about our tier 0 gateways. So there's different ways we can deploy our tier 0 gateways. And technically speaking, if you just look at this from just an NSX perspective, you get your tier 0 gateway. You're going to give it an edge cluster. So here's my edge cluster, edge cluster. This edge cluster, this tier 0 gateway can be active standby. So you see in this picture here, this edge 2 is all the traffic is going through edge 2. Edge 1 is doing nothing. If edge 2 dies, everybody fails over to there, and now edge 1. Active standby, okay? Nothing new there. I talked about that in the routing lecture, okay? So my tier 0 can be configured as active standby or active. Both edges in the cluster, again, this is the cluster here, the edge cluster. Both edges, traffic is flowing through both of them. So this is your choices. When we go to deploy our tier 0s, we can say, I want my location to be active standby or active. Okay? So let's take a look at this. So I just talked about active standby and active, and that's at the location. How about between locations? So this is where when we talk about locations, you can have primary and secondaries. So in this example, we've got our tier 0s are configured as active standby. So notice inside each location, I got location A on the left and location B on the right. You see this cluster here, this edge cluster on the left. This is active standby. So edge 2 is the active one. Everything's going through edge 2, which is great. Edge 1 is just sitting there as a backup. All right. Now, so active standby. We see that the green is active, the red standby. Green is active, the red standby. Okay. Now, when we talk about location, you'll notice location is primary and secondary. So the location A is the primary in this example. All right. It's the primary. So all traffic is going to flow in and out of location A. So any traffic going to location B has to come through location A across this active edge and then gets distributed down to the workloads. And same thing with traffic coming out. It's got to go across the edge over here. And again, notice we got our active edges talking to each other. Traffic's going in and out over here. And again, if one of these should fail, the other one becomes active. Now, if the location should fail, and I'll talk more about this in DR, you got to manually promote this secondary to a primary, okay? So it's not like it happens magically. I'll talk about DR when I get into multi-site and federation, and we'll do comparisons on that. But for now, we'll just stick with this terminology. So when I look at this picture, I do not have what's called local egress. There is no local egress. Everything's going out this one site and coming in, which is probably okay for you, right? Let's look at this one now. Same thing, pretty much, but notice our locations. The tier 0s are active. So now both the edges, traffic is flowing through them, both of them. Unlike the other one, we see the reds no traffic's going through it. But we still have, our locations are still considered primary. So location A is the primary and location B is the secondary in this case. And again, just imagine I had up to 8 locations. I'd have 7 secondary locations and all the traffic would be going through location 1. So same thing as before, all traffic's going in and out location 1. The only difference here is now is these clusters are running active. So that means you're using equal cost multipathing up here to do your, I don't like saying load balancing, but load distribution, okay? And again, like I said, all traffic comes in and out of the primary location. Doesn't matter where it's coming from, okay? If your primary location should fail, again, you manually make this primary at that point, okay? All right. Now this is what we, and again, so in this example and the previous one, there is no local egress. So that's a term most people probably more familiar with. In this example, we got active, and we got our location set as all primary. So you'll notice location A is a primary, location B is a primary, and so on. Okay, so I have multiple locations here. This is, in a nutshell, local egress. All traffic going out goes out through the location. Inbound traffic, on the other hand, can get a little bit challenging. Are you load balancing across it? Yes or no? So you might have traffic coming in this location and then going back over here, which may create some problems with asymmetric routes. So your physical firewalls generally don't really like that too well. So your inbound traffic, you're gonna have to figure out, okay, how do we want to do this, right? Do I want all traffic coming in or just distributed? You may have a network down here that you're advertising out to the real world. Are you gonna advertise the routes from the physical world coming in? Are you gonna advertise them equal? So both paths will be used, or are you going to put a higher weight, let's say, over on the a higher administrative distance over on the right side, so all the traffic for that segment comes in through, let's say, this side here. So your inbound traffic is something you're going to have to kind of think about, right? And how you can do that. Hey, by the way, any suggestions on that, leave it in the comments as well. I'd love to hear any conversations on that, because there's a couple of ways you could use load balancers, you could use DNS entries, you could use routing entries, all that kind of stuff here, right? So active, you now have local egress. You got to keep in the back of your mind now, how's the stuff coming in? Are we okay with asymmetric routes? In other words, something coming out this way from a workload here and then coming back in this way to go back to that workload. Your firewall over here, your physical firewall may say, asymmetric, it's sorry, and drop it, right? So now in this one, I decided to throw this one here as well. This one is, we still have all locations as primary, but our gateway is running active standby, okay? So still local egress, but only active standby on your, this is not supported. Okay, I just wanted to put that out there. It's not a supported configuration. Whether it works or not, it's one thing, okay? Now gateways. So if we back up the slides here, if I go all the way back to here, come on. Come on. Here we go. We're going back. There we go. Sorry. All the way back to here. So again, this is how we could deploy our tier zeros. Okay. And that's kind of what I just went through. Now, how about your tier ones? Now, your tier ones, how can we deploy those? And it's just like just basic NSX. You deploy your tier one, and if you have no services on it, it does not need an SR component. It only needs a DR, distributed router component. No problems. It's easy peasy, right? You basically, I'll call it local egress to the tier 0, right? At that point, what happens up here is what we just discussed in the previous slides. Is it all locations primary? Is it active standby? That type of thing, right? So you got to go back to the other slides to see how it's handled up here. But again, this one here, stretch tier 1, piece of cake. I'm stretching it across location. I got no services. Life is wonderful. Life is easy. Now, as we know, just regular NSX, if you deploy a tier 1 gateway and you put a service on it, right? Let's say I'm going to put a VPN service on it or something like that, right? At that point, it needs an edge cluster, and because it needs to instantiate an SR, services router. If you're not sure what I'm talking about, watch my routing video, okay? So it needs to instantiate an SR component now, and at that point, it needs an edge. And that SR component is going to run active standby, okay? So that's what we see here in this picture. So it's showing me, okay, if you decide that you're going to deploy, I probably should have put a service on this little icon here. Maybe NAT or firewall. Actually, I probably shouldn't have said firewall. I'll say VPN. Okay. So again, the tier 1 will run active standby. All the traffic will go through a single edge node, and then the other standby is backup. Okay. So let's see how this looks like in Federation. And this is the part where it gets potentially weird. Okay, and something you really got to think about. So somebody decided to deploy some services over here. Now, before I get comments down below, I think it was version 4 something, I can't remember. We do now support active on a tier 1 edge. Sorry, on a tier 1. Sorry, let me back up. I can't remember the version. It's 4. Whatever. We do now support active on our tier 1s with a firewall, with the firewall solution. But I don't think that's supported in Federation as of yet, because I have not seen it. Okay, I'm looking at all the documents, and this is as of 4.1 whatever we're at right now, and I have not seen any change in that. Okay, so I'm just going to stick with this and say, so talk to your TAM or technical account manager. So in this example, we decided we're going to stretch a tier 1 and we're going to put services on it. What does that mean? I need an edge now, and I need that SR component. Now notice, again, this is an edge cluster at this site. This will be an edge cluster at this site, and you have up to 8 sites, edge clusters, and you'll have to pick that, right? Each inside that edge cluster, there'll be an active one and there'll be a standby. Okay, so locally, again, any traffic going out of this tier 1 will go through that edge node at location 1. Okay, and how about location 2? Again, any traffic going out that service, or that tier 1 will go through its active edge, and in this case, it's got to come across over here, because it's basically like a primary secondary site, because this is now the active, and it's got to come up through this way. So imagine if you had 8 sites here and they're all firing their stuff out like this. So that could get a little challenging, because that service is running actively on this one here. So something to think about if you decide you want to stretch your tier 1s and you want to put a service on it, that might be a bit of a challenge. The previous slide here, sorry, not the previous, this one here, piece of cake, right? You don't even have to worry about any of that stuff. So that's the nice thing about not putting a service on it. Okay. Now, how do we do the stretching of the networks? I need to talk about this thing called remote tunnel endpoints. Again, if you've been watching any of my videos on NSX, we have these things called TEPs, tunnel endpoints, or you can call them VTEPs, virtual tunnel endpoints. And a tunnel endpoint basically takes our layer 2 frame, encapsulates it inside Geneve. So the tunnel endpoint does encapsulation and decapsulation of our Geneve frames. Great. Watch my other videos on transport nodes if you're not sure what I'm talking about. So how do we do this how do we do the stretching of the network between locations? That's where these remote TEPs come into play. So they're used to span segments between our locations. I'll show you that in a second. They are configured on edge nodes. So we configure our RTEPs on our edge nodes. It's required if the edge cluster is used to span a gateway to one or more locations. So when you're spanning a gateway, it's going to say, hey, you know what? You need to pick an edge cluster, because remember, when you attach a segment to that gateway, it's got to stretch it, and it goes through this RTEP. So it says if an edge cluster is used to span the gateway one or more locations. All edge nodes in the cluster must have an RTEP. So when you say, this is the cluster I'm going to use for my stretched gateway, all the edge nodes in that cluster will get an RTEP. A single RTEP on the edge node today. We don't support multi-RTEP as of today, and I think we're at 4.1.2 or something like that. Not required for all edge clusters. Yeah, I may have other edge clusters doing other services, and that's fine. I don't need an RTEP on every edge in my environment, just the ones I'm using to stretch my gateways. The default MTU is 1500, 1700 is recommended. I don't know if that default's actually changed, to be honest with you. So what is this RTEP? So in this example, let's look at, I got location A on the left, location B on the right. Again, imagine I have up to 8 locations. I decided I'm going to create a stretch segment across there. Okay, I know I said you don't create a stretch segment, you attach it to a stretch gateway. All right, tomato, tomato, right? So anyways, I got a stretch gateway, and now I have a stretch segment. Notice again, here's my segment. It has a virtual network identifier. I just gave it this is a global VNI of 9999, whatever, okay? The global manager is responsible for assigning that. Now what happens is when this segment gets stretched across the locations, global manager says, hey, local managers, you need to create a segment at each of your locations. So each local manager will say, all right, no problems. I'll create a segment here, and this the local managers here. I'll say the local managers here, and the local managers over here created this segment, and it gave it its VNI of 777 in this case, right? And same thing over here on the right at site B. or location B, it created a segment and called it VNI, whatever, get an idea, VNI 8888. Beautiful. Now we have this concept. Here's our TEPs that we're used to. Here's our edge node. Nothing's different there. So when VMs want to talk to each other, if a VM from here wants to talk to each other, it comes out of the TEP, gets encapsulated, arrives at the other TEP, gets decapsulated, and then sent up to the VM. Beautiful. Nothing new there. Now, how about if the VM over here wants to talk to the VM, let's see, you pick a different, the VM way over here. Well, what happens here, remember we talked about the VTEP, MAC, and ARP tables? Well, what will happen here is we do not create tunnels between all your TEPs with all your locations. That would just be way too many tunnels to manage, too much overhead, and it wouldn't be that efficient. So what we do is we have these things called RTEPs, and think of it like a proxy almost. We'll say, oh, okay, you know what? If this VM over here wants to talk to this VM on location B, we got to go through this RTEP group, let's say. Okay, there's a group of RTEPs. It goes through this, and all this is transparent to you, right? So inside our VTEP, MAC, and ARP tables, you'll see these mappings. You'll see the MAC address for this VM, but it will not show you that it's on this tap. It's saying you're going to this RTEP group to get over there. So what happens here in this example, if the VM on the left wants to talk to this one on the far right, it'll come down, we'll hit the tap here, right? Its job is to encapsulate it. So it encapsulates inside Geneve, and we know we got to go over to our edge node for our tap, okay? So this tap over here decapsulates it. So I'm going to take that payload and remove it. Now, so there we go. There's our payload that left here, okay? And we're not talking about routing. This is just one segment, okay? The RTEP's job is now to encapsulate. I'll use a different color here. Maybe I'll use yellow. So it'll encapsulate that, and this is my RTEP encapsulation, which is Geneve. Bad color I chose, okay? You tap over here, the RTEP on this cluster will receive it, decapsulate it, and then send it to its tap, and then it's going to encapsulate it in Geneve and then fire it across over here to that tap. That tap will decapsulate it and send it up to the VM. So you see the purple I got is just your normal Geneve encapsulation that we've been playing with, that we're used to, that we've been talking about for quite a while. But the one in yellow is that RTEP to RTEP. It's still Geneve. It's still the Geneve encapsulation. The beauty of this solution here is, now, one of the things I've always said, down here, you need a minimum of 1,700 bytes for your MTU. End of story. If you got 9,000, great, rock and roll. But a minimum of 1,700. Okay, is from VMware's recommended minimum. Absolute bare bone minimum would technically be 1,600, but anyways. But between sites, sometimes the challenge is between sites because maybe you can't go with jumbo frames, so you only got 1,500 bytes between sites. This would work. So what this is telling me is our TEPs, our TEPs, so the TEPs down here in your transport node that you're used to, do not allow for fragmentation of the Geneve frames. If it receives a Geneve frame that's been fragmented, it's sorry, and it drops it. It's basically coded in the software. Whereas the RTEPs, on the other hand, will allow for fragmentations. Not recommended, obviously, but you got no choice. You got no choice, right? So it will work if you only got 1,500 between the sites. It will do fragmentation. Again, not recommended, but it will work. But again, if you can, crank it up to 9,000 if it's possible. So when I look at this RTEP, what is it doing really? These guys are it's acting as a bridge. So I've got a segment here on the left, segment on the right, and this is a bridge that's bridging the two, a layer 2 bridge, if you think about it. So it's got to keep the mapping. By the way, it's got to keep the mapping of that. It says, oh, VNI 777, oh, that has to be mapped to VNI 888, right? And by the way, you see that there's another VNI over here. So again, if you're sniffing packets and you're looking at Geneve headers, going from left to right, you'll see the Geneve VNI identifier gets changed. And again, but that's totally transparent to the VMs. They don't realize any of that stuff is going on. They just see the original frame, and then that's it. Life is good, right? So that's what an RTEP is. Now, a couple things here. I just drew, this is an edge cluster on site B, and this is an edge cluster on site A. I only drew one edge in there just to keep the diagram simple. You would have multiple edges in there. If this cluster here had 8 edge nodes, I'd have 8 RTEPs, okay? Or whatever, okay? Yeah, I think that's about it. So that's what an RTEP is. This allows us to stretch our network across these locations. And, the easiest way to look at it is think of it as like a bridge. It's kind of what a bridge is doing. That's it for the networking part. Now, what about security? This is actually a slide I kind of pulled out of a slide deck I found on the communities. Anyways, so with security now, this is one of the big advantages of Federation, is you can create these things called global groups. So again, if you haven't watched the distributed firewall lecture I done, watch that. We can create what's called global groups. We could also create regional groups, and we could also create local groups. You see how the local groups are just specific to each location. This region here is specific to locations 1 and 2. So we can do this all day long. So I could create a global group, drop a bunch of VMs inside it. I can create regional groups, drop a bunch of VMs inside it, and I can create local groups, drop a bunch of VMs inside it. I could then create firewall rules that could utilize any of these. I could create firewall rules saying this global group can't talk to that local group, or whatever the case may be. You could do stuff like that. One of the things to watch out for when you're getting into these firewall rules, and if you haven't watched my distributed firewall lecture, is the applied to field. So you want to be very conscious about your applied to field. Imagine you left it at the default applied to every VM, and you got 8 locations here. Right? Probably not the most efficient way of doing things. So you got to be careful about that applied to field. I'll, like I said, when I get my Federation stuff up and going, I'll do some demos on that as well. These groups, by the way, could also be populated dynamically. Here they're showing you NSX tags. Don't get this confused with vSphere tags. These are NSX tags. You could use NSX tags. You could use the name of the VM. You got all that flexibility that we talked about before in the distributed firewall. So this allows me, if I move a VM from one location, the tag follows it, lands at another, the security posture stays there. Okay? So keep that in the back of your mind, especially if you're... If, for example, one of the things I would really watch out for, let me change the color here on this. Let's say I created a regional group here, and these VMs are in that regional security group, okay? So I created that in the global manager. These VMs are now connected to a segment that's stretched across all locations. To me, that's kind of a massive yellow flag, because now if I move this VM over to this location, it's no longer part of that group, and I may circumvent firewall rules. So you may want to watch that. Look at the span of your groups, okay, and the span of the segment. Like in this example, these VMs are on a segment that spans all locations. I'd make that a global group at that point. So then I know if the VMs go back and forth, the security posture stays the same, right? But if it doesn't, if that segment only spans here, maybe this is, like I said, location 1 is Toronto. I'm Canadian. Toronto, Montreal, and I'll throw in New York over here. So this region might be Canada, and this over here might be region USA, something like that, whatever, okay? So that's pretty much it. So requirements, I talked about some of these things because as of 3.2.1 now, global manager cluster to standby cluster is 500 milliseconds or less. Global manager cluster to local manager cluster is 500 milliseconds or less. Local manager to local manager, 500 milliseconds or less. RTEP to RTEP, and I talked about the RTEPs, that's still at 150. So technically speaking, if you decide you're going to do stretch networks, which you're probably going to do, to be honest with you, you still have this 150 milliseconds between sites. Okay? So, let me scratch that off there. Okay? IP and firewall connectivity, global manager to local manager connectivity, no NATing allowed and for management traffic, so no NATing. Edge nodes connectivity without NAT as well, so we need, true IPs. WAN bandwidth, they don't really see any kind of recommendations. They basically say no congestion as fast as possible, that type of thing. WAM MTU, I talked about this. So the MTU size between the locations, you don't have to be using jumbo frames. So it would work with 1500. It would do fragmentation, as I pointed out, but it's not recommended. So if you can increase the MTU size between the sites, go for it. Recommended minimum from VMware is 1700. Okay, but if you can go larger, go larger. Okay. That's it, everyone. That's it for Federation. A quick little nutshell on what it is. That's part one. Part two will be me demoing it. I'll be setting it all up and creating, global objects and all that wonderful stuff. So I'm just get my lab prepared for that. So look out for that in probably about a week or so. And then I'll be doing after that a multi-site disaster recovery, right? So we'll see you in a bit. By the way, if you found this entertaining, liked it a little bit, hit that thumbs up. I'd appreciate it. Subscribe to the channel if you haven't already done so. If you have subscribed to the channel, again, it's free to do, right? So just hit the subscribe button. If you have already done it, I really appreciate it. Thank you very much for those of you that are supporting the site or supporting the channel. I appreciate it. But that's it. Have a great evening. See you in the next one. Bye now.